Welcome to VTeach. So in this lecture, we are going to proceed further with the newer topics related to software testing. We will discuss on the model for testing, effective and exhaustive testing. What is an effective testing and what is exhaustive testing? Model for software testing. So with reference to this, so we have to understand initially that testing is not an intuitive activity. It should be viewed as a process. It is a continuous activity. It is not a separate activity. It is a continuous activity and it should be viewed as a process. So the model for testing could be viewed like this, the one that is shown here, wherein which the major components are the system, the developer. Systems and developer. Systems are the hardware and software that make the product run. Developer is the individual who constructs the software. Together these two contribute for the software. This is the part of the system for which it is being developed. So this is actually what we have to test here. Tester, he begins the tasks as soon as they get the requirements and work on the bug model. Bug model, we will classify the types of the bugs here. Based on the type of the bug, the tester starts working, begins his task as soon as he gets the requirements and works on the types of the errors. So this bug model is the one which classifies the errors, classifies the bugs based on the criticality, what sort of damage that they could cause to the system. Criticality refers to the it is based on the amount of damage that they can cause to the system. So nature of the bugs and psychology of testing depends on the criticality of the bugs. Then the testing methodology will identify here. This depends on the type of the software and the bug model. Based on the type of the software and type of the bug that we have, we will identify a testing methodology, and then proceeding further, we will perform the testing activity. We will identify suitable testing technique, or we will identify suitable testing tools, methodologies, and we perform the testing. Based on this, we will obtain the results. If the results are expected, then we can stop the testing process. If the output of the product is expected, we can stop the testing process. Otherwise, if we have some unexpected results, or is there any deviation from the actual output from the expected output, then we will come back. We will classify the software based on the bug model, we will refine the testing methodology, we will apply the testing methodologies tools, and then we will perform the testing activity again. This complete model is the model for software testing. So the entities here, system, the hardware or the software that is used to develop the corresponding product, developer, the individual involved in developing the product, software is the actual element that is developed, the actual product, part of the product that is developed, tester is the individual who performs the testing activity. Based on the criticality, we will classify the bugs, that is the bug model. Based on these two, the software and the bug model, tester's intuition, testing methodology, tool or technique is identified. We will perform the testing here based on the results obtained. If the results are as expected, we will terminate the testing process. If the results are not as expected, we will repeat the process. Based on the software, based on the type of the bug, tester chooses the testing methodology and proceeds further. This is the model for software testing. We will refer to two terms here, effective and exhaustive testing. Effective and exhaustive testing. Exhaustive, this refers to complete. If anybody comes to you and tells, I have tested the product completely, it is a sheer wrong, it is a mistake. Completely, it's a mistake. Complete testing is always not possible. Exhaustive testing is not possible. Never aim to perform exhaustive testing. Why? The reason is, the domain of possible inputs to the software is very large. The domain of possible inputs is very large. As an example, we can discuss, if we have developed a small addition program itself, if at all I want to add two numbers a plus b, we have to test this algorithm with the valid inputs. We can take 2, 3, or invalid inputs. Have we written the program for floating point values 2.5, 8.3, edited inputs, some inputs that are corrected, and we might have to test our program where it involves race conditions when it is actually aiming for the same resources. These inputs also have to be checked. So, which refers to that the input domain is very large. That is, we have to test our program with valid set of inputs. Invalid inputs, we cannot give the decimal values if we have written a program for integer values, right? If at all I want to test completely for the integer values, so that is also the valid input set goes very larger. Modified inputs, that also is larger. When your program involves resource utilizations competing for the same resources, I might have to check for number of input values that compete for the resources, race condition inputs. So, which summarizes that the domain of input values is very large, and moreover there will be too many paths to the program to test. So, if we write a program which involves number of condition statements, number of looping statements, in that case I might have to check number of paths in the program to test. See, if it involves 40 to 50 conditions and 40 to 50 loops, imagine the number of paths that we need to test in the corresponding program. We might have number of design errors in the software even, and every design error cannot be found. Tester cannot directly identify all the design errors. So, some of the errors are hidden deep inside the product design. So, that cannot be found. So, that is the reason why exhaustive testing is not possible. Complete testing is not possible. One should not aim at exhaustive testing. For that reason, we need to check for effective testing. We need to identify a good set of test cases and see that it explores number of errors. So, it is difficult but achievable, but exhaustive testing not possible. So, effective testing is difficult or hard because defects are hard to find. So, we need to perform certain test conditions that are never tested. Moreover, developers may overlook and leave certain parts untested. So, developers, when they perform unit testing, soon after they write a simple snippet of code, they give a sample input and test the corresponding small part of product that they develop. So, that also developers may overlook certain set of inputs. For this reason, effective testing is difficult, but once we are cautious, we can achieve effective testing. In order to have this effective testing, we need to identify when to stop the testing process. We need to identify a criteria. We need to see a threshold point where to stop testing process. Boss, it is enough. Now we can stop the testing process. So, effective testing categorizes that we need to define a criteria to stop the testing process, when it is enough to stop it. When we explore more categories of errors, when the test suite or the set of test cases that we develop could explore more set of errors, that testing phenomena is effective testing. So, one should aim at effective testing rather than exhaustive testing. Thank you.